Hello everyone. In this video I will be describing the topic Euler Circuit, and I hope you might have come across a popular puzzle given by one of your friends. That is, you might be asked to draw these diagrams without lifting the pen from the paper and drawing each of the line segment exactly once. As an extra challenge, you might have asked to finish the drawing from the point where you started it. Okay. You can pause the video and try to draw these diagrams with the conditions that I just mentioned. Alright, how did it go? So let me also give it a try. So I'm starting from this point, then I'm drawing this line first, then this one, this one, this one, and this one. Okay, so I have managed to draw this diagram with the specified conditions. Now let me start from another point. If I start from this point, let me draw this diagram. So I'm drawing this way, then this way, then this way, and from this point if I draw either of the line, then I will not be able to come back. So let me draw this line, and if I want to draw this one, then I have to trace this line again, then it will be violating the condition. Okay, so let it be there. Now let me draw the second diagram. I'm starting from this point and let me draw it from here. So I'm drawing this line, this one, this one, this one, here, here. Okay, so I have managed to complete this diagram, but you can note that I have finished the drawing from the point that I have started it. Okay, now let me try the last diagram. So if I start from this point, then this one, this one, this one, this one, and this one. Okay, so I'm not able to draw this line. So we have seen that we are able to draw this diagram starting from this point and finish at this point, and we are not able to complete the diagram if I'm starting from any other point. Okay, for this diagram we managed to complete the diagram. One advantage is that we have managed to stop the drawing from the point that I started. So as far as this diagram is concerned, I am not able to complete it at all. And the question is, why were we able to draw some diagrams while we are not able to draw other diagrams? And moreover, why do we discuss such a puzzle in graph theory? So if you look at these three diagrams, you can see that we have modified the previous diagrams a little bit. So each corner are marked with vertices of the graph and each line segment is marked as edges. Okay, so we can transform the original diagram into the form of a graph. So once that is in the form of a graph, then you can solve this issue by using graph theory. Now the applications of such problem in real life is, imagine that these green points are junctions of the road, and you have to start from this point and you have to finish at this point, and you are allowed to travel each of these line segment exactly once. And if you travel each of the road more than once, then you may suffer extra cost. Okay, in the second diagram you consider this as a post office, and the postman has to deliver letters in all over the city, and if he travel any of the road multiple times, that may cause him inefficiency. So the postman has to travel each of the road exactly once, and he has to come back to the post office after delivering the letters. So you can use the previous puzzle in order to solve the real life problems that I just mentioned. Now coming to our topic, the first topic that we need to discuss is the Euler path. Okay, so the Euler path is a path that uses every edges of the graph exactly once, and if you want to have a Euler path in a graph, then exactly two vertices with odd degree must be there. Okay, so there should be exactly two vertices with odd degree. If there are more than two vertices with odd degree, then you cannot have an Euler path. Okay, and these odd degree vertices must be the starting and stopping vertices of the Euler path. So what is the degree of a vertex? So degree of a vertex is the number of edges connected to it. So if you look at this diagram, you have four vertices and this has three edges connected to it, or the degree of this vertex is 3. the degree of this vertex is 2, and this is 2, and this is 3. Okay, so you have exactly two vertices with odd degree, and you can start from this point and finish at this point, then you will get an Euler path. If you are starting at any other vertices, then you will not have an Euler path. Okay, now let's come to the Euler circuit. An Euler circuit is a Euler path. The difference is that the path starts and stops at the same vertex. So it will be a closed path. That's why we are calling it as a circuit. So the condition for a Euler path is the graph should be connected. Connected means you should be able to travel from one vertex to any other vertex, and all vertices should have even degree. So if you look at this diagram, the degree of this node is 2, this is 4, this is 4, this is 2, and 4, and 4. Okay, so you can see that you have all the vertices with even degree. So you can have a Euler circuit in this particular graph, and you can start at any of these vertices and you can finish at the same point. And if you look at this diagram, the degree of this node is 3, and this is 3, this is 3, and this is 3. Here you have more than two vertices with odd degree, so you cannot have an Euler path in the circuit, and also the degrees of every node are odd, which are not even, so you cannot have an Euler circuit. So that is why we were not able to draw this diagram with the condition specified. Now let's look at how we can find an Euler circuit in a graph. So I have listed the steps here. The first one is visit a portion of the graph and return to the starting point prematurely, that is without visiting all the edges. So let me work it out along with the description, and I have a graph here and vertices are marked with some numbers, and I'm starting from this point, then I'm visiting a portion of this graph and I'm coming back to the same point prematurely, that is without visiting all the edges. The path I just traversed is 1, 2, 3, 1. So I'm removing the path I have already visited. I have visited this one, and this one. Okay. Now if you look at this path, the first vertex that has unvisited edges is this node 2 or the vertex 2. So this vertex has several unvisited edges. So I will start from that particular vertex, that is 2. So from 2 I'm starting, then I'm visiting a smaller portion of this graph, so I'm coming back to the same point again. So the path that I just visited is 2, 4, 5, and 2. So I will write 1 instead of 2. I will write that entire path, that is 2, 4, 5, 2. So I'm writing 2, 4, 5, 2, then the remaining part, that is 3, 1, 3, 1. So I have visited this one, and this one. Okay, now if you look at this path, you have to find the first vertex which has unvisited edges. So in this one, 4 is a vertex which has unvisited edges. Now I am considering the vertex 4 and I am starting from that vertex. So starting from that vertex 4, I am visiting 4, 3, 5, 6, and again 4. Now I am inserting that path into this sequence. So instead of 4, I will be writing the new path. So I will write 1, 2, then instead of 4, I will write 4, 3, 5, 6, again 4, and the remaining part. So that is 5, 2, 3, 1. So I am removing the edges that I have just visited. So this one, this one, this one, this one. Okay, so now we do not have any edges which are unvisited. So this is my Euler circuit. Okay, that is I am starting from a point and I am finishing at the same point. Now if you trace this path in this diagram, I am going from 1 to 2, then 2 to 4, and 4 to 3, then 3 to 5, 5 to 6, 6 to 4, 4 to 5, 5 to 2, 2 to 3, and 3 to 1. Okay, So I can complete this diagram by drawing all the edges exactly once, and I can come back to the same point where I have started. In this diagram, you know that there is an Euler path existing. So in the case of Euler path, you have to find a smaller path which start at the starting point and end at the another ending point. The peculiarity of the starting point and ending point is it should have odd degrees. Okay, so I'm starting from A, then I'm going to C, then I'm going to D. So I have already considered this path, that is, this is considered. Now in this one, the first node which has unvisited edges is A. Now I will have to find a path that starts at A and end at A. So I am selecting the path A, D, B. So instead of A, I will write A, D, B, A. Then I will write the remaining part, that is C, D. Okay. Now if you traverse along the path that we have just found, then we will be drawing it as A to D, then D to B, B to A, then A to C, then C to D. Okay, so this is how you can complete an Euler path. I hope the concepts are clear. Thank you.